Do you know how much carbon dioxide the oceans absorb every year? Do you know what happens to that carbon dioxide once it enters the ocean? And do you know what are some of the ways that scientists are trying to enhance the ocean's ability to remove carbon dioxide from the atmosphere? Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today we're going to talk about how the oceans can help us fight climate change. Climate change is one of the most urgent and complex challenges facing humanity today. It is caused by the accumulation of greenhouse gases, such as carbon dioxide in the atmosphere, which trap heat and warm the planet. The main source of these greenhouse gases is the burning of fossil fuels, such as coal, oil, and gas, for energy and transportation. To avoid the worst impacts of climate change, such as rising sea levels, extreme weather events, biodiversity loss, and food insecurity, we need to reduce our greenhouse gas emissions as much as possible. But that may not be enough. According to a 2019 report by the National Academies of Sciences, Engineering, and Medicine, we also need to remove about 10 billion metric tons of carbon dioxide from the air every year by 2050. That's equivalent to the annual emissions of about 2 billion cars. But how can we do that? Well, there are several possible ways, such as planting more trees, storing carbon in agricultural soil, or capturing carbon from power plants and industrial sources. But there is another option that may not be as obvious: using the oceans. The oceans are the largest carbon sink on Earth. They absorb about a quarter of the carbon dioxide that humans emit into the atmosphere, or about 2.5 billion metric tons per year. That's a good thing, because it means that there is less carbon dioxide in the air to warm the planet. But it also has a downside. It makes the ocean more acidic, which harms marine life, especially corals, shellfish, and plankton. So, is there a way to make the oceans absorb more carbon dioxide without making them more acidic? And can we do it safely, effectively, and ethically? That's what some scientists are trying to find out. In a new report published in December 2021, the National Academies of Sciences, Engineering, and Medicine assessed the feasibility, cost, and potential impacts of 6 ocean-based carbon dioxide removal approaches. These are methods that aim to enhance the natural processes that take carbon dioxide from the air and store it in the ocean or in marine sediments. The report also recommended a new research program to learn more about these methods and their risks and benefits. Let's take a look at what these methods are and how they work. The first method is called ocean alkalinity enhancement. This involves adding minerals such as limestone or olivine to the ocean to make it less acidic and more alkaline. This would increase the ocean's capacity to absorb carbon dioxide from the air and store it as bicarbonate ions in seawater. It would also help counteract ocean acidification and its effects on marine life. The second method is called electrochemical alkalinity generation. This involves applying an electric current to seawater to split water molecules into hydrogen and hydroxide ions. The hydrogen can be used as a clean fuel, while the hydroxide ions can react with carbon dioxide to form bicarbonate ions, which can be stored in seawater or in marine sediments. This method would also increase the ocean's capacity to absorb carbon dioxide and reduce ocean acidification. The third method is called ocean fertilization. This involves adding nutrients, such as iron, phosphorus, or nitrogen, to the ocean to stimulate the growth of phytoplankton, which are microscopic plants that live in the ocean. Phytoplankton use carbon dioxide and sunlight to produce organic matter and oxygen through photosynthesis. Some of this organic matter sinks to the deep ocean or the sea floor, where it can be stored for a long time. This method would increase the ocean's biological productivity and carbon export. The fourth method is called marine biomass cultivation. This involves growing seaweed or other marine plants on a large scale in the ocean. These plants also use carbon dioxide and sunlight to produce organic matter and oxygen. Some of this organic matter can be harvested and used for various purposes, such as food, feed, fertilizer, or biofuel. The rest can sink to the deep ocean or the seafloor, where it can be stored for a long time. This method would also increase the ocean's biological productivity and carbon export. The fifth method is called ocean macronutrient removal. This involves removing macronutrients, such as nitrogen or phosphorus, from coastal waters or wastewater before they enter the ocean. These nutrients can cause eutrophication, which is the excessive growth of algae and other organisms that deplete oxygen and harm marine life. By removing these nutrients, the ocean's biological productivity and carbon export would decrease, but so would the negative impacts of eutrophication. The sixth method is called enhanced weathering of coastal sediments. This involves increasing the exposure of carbonate or silicate rocks on the seafloor to seawater. These rocks can react with carbon dioxide and water to form bicarbonate ions, which can be stored in seawater or in marine sediments. This method would also increase the ocean's capacity to absorb carbon dioxide and reduce ocean acidification. These methods sound promising, but they also have many challenges and uncertainties. For example, how effective are they at removing carbon dioxide from the atmosphere and storing it in the ocean? How durable is the carbon storage, and how can we monitor and verify it? How scalable are these methods, and how much would they cost? What are the potential environmental, social, and ethical impacts of these methods, and how can we minimize them? And how can we govern and regulate these methods to ensure that they are safe, fair, and transparent? These are some of the questions that the new research program proposed by the National Academies of Sciences, Engineering, and Medicine aims to answer. The program would involve scientists, engineers, policymakers, stakeholders, and the public in a collaborative and interdisciplinary effort to advance the knowledge and understanding of ocean-based carbon dioxide removal approaches. The program would also develop and adhere to a common code of conduct that emphasizes transparency and public engagement and promote international cooperation and governance. The report does not advocate for or against the deployment of any of these methods, but rather provides an objective and comprehensive assessment of their potential and limitations. The report also emphasizes that these methods are not a substitute for reducing greenhouse gas emissions, but rather a possible complement to other climate change mitigation efforts. Ocean-based carbon dioxide removal approaches are an emerging and intriguing area of research that could offer new possibilities for addressing the climate crisis. But they also pose many challenges and risks that need to be carefully evaluated and managed. The new report by the National Academies of Sciences, Engineering, and Medicine provides a valuable roadmap for exploring this frontier of science and engineering. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.